Alright, in this video, we're going to be spending some time talking about tectonic plates and how they move. Going back to the syllabus document, which I like to come back here to help us to take a look at what's important. Now, so I've highlighted this point here, the movement of crustal plates driven by, and even in the syllabus document, we see that there are two main processes, right? One, driven by the pull of subducting plates, and that's what we call the slap pull force. And the second process is convection currents circulating within the mantle. It's not complex, it's two main things we need to know. So coming back to tectonic plates now, first of all, what are tectonic plates, right? What is a tectonic plate? A tectonic plate is basically a part of the Earth's crust that's floating on the surface of the Earth, or rather floating on the mantle. You will see words like lithosphere and all that, and that's fine. And the lithosphere basically comes from the word lithos and sphere. Lithos stands for rock in Greek, right? So lithosphere is the rock sphere. And the tectonic plate is a piece of the Earth's crust that's on the mantle. It can be broken up into continental crust, which is thick and less dense, and oceanic crust, which is thin and dense, right? I'm going to skip quite a bit of this. I'm going to go through it very fast. If you need to know what are the differences between oceanic and continental crust, just note these few points. One is made of basalt, which is thin and dense. The other made is granite, which is thick and less dense. In fact, Singapore, as they say, only has one natural resource. What is that? It's, of course, granite. It can't be basalt, right? It's granite. And that's what some people say our only natural resource. If today you go to Siao Kuei Ling at Bukit Gombak, you see our granite quarry, right, where there's a whole bunch of granite there. Okay, no time here to talk more about granite and basalt, but take note, why is this slide important? Because basically, oceanic crust will subduct beneath continental crust. Now, I'm going to fast forward and zoom into this. What causes the plates to move? Now, this is really important. Remember, the syllabus doc needs you to master these two, convection currents and slap pull force. Okay, convection currents is not difficult. Again, you see it all the time when you boil water, right? What's difficult for this description is basically you got to break it down into steps. And basically, to revise, step one, mantle material is heated by the core, it becomes less dense, and then it rises. Once it rises, it spreads out beneath beneath the plates, and then once it cools down sufficiently, it sinks, right? Now, as that is happening, the plates are being dragged along, right? And as you can tell in this diagram, they are being dragged along at the point where the mantle material is moving up. Because at the point where it moves up, it drags it away from each other. And then when it sinks, it's dragging the plate to a point of convergence. So where the convection currents are sinking, that's where you find convergence. When the convection currents are rising, that's where you find divergence. Okay. Of course, this is the next two steps of the convection current, which I've already said. Cools, sinks, and then this cycle repeats. And it's a convection current, okay? Last point from me for this video is slap pull force. Slap pull force, again, is not complex. It's basically that when a plate is sinking, it pulls the rest of the plate behind it. The slab, right, it comes from the word slab. The slab of crust is pulling the rest of the crust behind it as it subducts. Right? And that's called the slap pull force. And some people think that that's the main driving force for plate movement. All right? So if the question comes out about why do plates move, how do plates move, explain the movement of plates, right? Well, the answer is convection current and slap pull force. And these two things must be in your answer, all right? And that's all for this video.